Hi, everyone. Good afternoon. I am Audrey Ronas-Tobin, Director of Marketing at Co-Strategics, and welcome to this webinar, Evolving Directions in Data Analytics Technology. We want to make sure that this webinar is conversational, so if you have any questions, please add them to the Q&A, and we'll try to answer them as we go along, or at the end, we'll have that option available for you too. Also, we are recording today's webinar, and yes, we will send you a link when it's posted. So now I'm excited to introduce you to our speakers, Jeremy and Matt. Jeremy Henry is Vice President of Engineering at Co-Strategics. He started his tenure as a solution architect and has since led the creation of growth of the data analysis and data science team at Co-Strategics. Jeremy enjoys solving difficult problems and democratizing the sometimes esoteric world of data technology to make it more accessible. We also have Matt Werman, who is Director of Enterprise Applications. Believing that data and curiosity foster a culture of innovation, Matt helps companies view their business from a lens that might not have previously been seen. When not working, Matt enjoys exploring Cincinnati with his family and supporting FCC, our hometown soccer team. And now let's get started.
Good afternoon, everybody. Thank you, Audrey. Today we want to talk through 6 different topics and talk through each of those a bit and how they're going to evolve over this coming year. So we include artificial intelligence, synthetic data, report, automate, iterate, active metadata, MDM or master data management, and finally local and systemic analysis. First topic we'll go through is artificial intelligence. So AI has received mostly balanced treatment in the press so far, if you noticed. For every story about killer robots, there are also stories about AI creating art or helping to find missing children. But the underlying question for most people is whether their own job will eventually be replaced by AI. Right now, it seems to be playing out like this. And I think this is a good way to phrase a response. Using radiologists as an example, radiologists who don't use ML are replaced by radiologists who do use ML. And similarly for artists, marketing people, call center operators, and so on, ML and AI are becoming a valuable tool, and using that tool will allow people to work better, faster than they could before. Economic forces will trend to favor workers who are adept at using the tool. If you don't use that tool, you will be at a competitive disadvantage. So, for instance, teams that are performing traditional tasks as sales and business analysis will start seeing new roles coming into those teams. You'll start seeing a role as a sales AI analyst, as marketing AI analysts, a business AI analyst, and these are new roles or jobs people can fill, provide specific AI and ML data modeling for those business functions. People filling these roles will know their specific data for those business functions and how to best model and use different models for that work. AI tools are becoming easier to use, so one doesn't necessarily have to be a data science writing only in Python to get the work done. As low-code solutions are coming available that allow users to easily plug in their data and start working with those models.
Now, it's good to keep in mind that most AI is not intended to play a role or work at a job. It's not intended to replace humans. In most cases, AI is simply intended to make decisions. And even in that limited space of decision-making, we're not expecting AI or ML to make all decisions. It falls along a spectrum of this automated, augmented, and supported. So if we start with this automated decision-making all the way on the left side of the spectrum here, an example of this is an AI that we would use to determine whether to route an incoming customer service call to an automated chatbot system versus sending over to a human call center representative. Then in a decision like this, the stakes are very low, mistakes are easily rectified. And the decision in this case has to be almost entirely automated because inserting a human into that loop, into that decision loop, would defeat the whole purpose. Next along the spectrum, you would come to an augmented decision making. So in this case, the AI is making a recommendation, such as like spotting potential anomalies on an area in a scan for like the radiologist that Matt was just talking about. The AI might point out areas of interest that the human should take a closer look at. In these cases, the stakes are higher, and inserting a human into that decision loop is probably desirable. At the far end of the spectrum, you have supported decisions. And the example here would be like building a new factory or building a new power plant. Now, this is a highly complex decision, and in this case, the stakes are very high. So in cases like this, it makes sense for the AI to gather the supporting information to help analyze that data. But then you're going to want to rely on the human to consider all those factors, consider all that data, and come up with that final decision. Now, one of the most rapidly evolving directions in AI is using ML or other algorithms to create new designs. So the act of creating and discovering used to be solely the realm of humans, but now that role may be changing. So this means that the nature of creative work may shift from that manually intensive act of creating or discovering. We may shift our focus to more on the side of editing or validating or curating those designs that were originally created by AIs. So an early example of this is this X-band antenna that was evolved for a 2006 NASA Space Technology 5 mission. So NASA needed a replacement for their standard quadrifilar helix antenna that was better adapted to a very specific use case at X-band frequencies. They used an evolution algorithm to come up with an antenna that had this unusual structure you see here on the right. And this antenna can actually outperform the standard antenna that had been used in the past. Now, how long would it have taken a human sitting at a drafting board to come up with this optimal design? A long time, years, maybe never. But once the AI was able to come up with that design simply by tweaking a design in small ways and then virtually testing the efficiency of that new design and then tweaking in other random ways, it could eventually stumble across an optimal design, but that only took a few days, and then another few days for humans to fabricate that design and then validate that it outperformed the original antenna. So now you're talking what can be done in a week or two, what otherwise might have taken years. And lately in the news, you've seen these next generation or natural language AI engines like ChatGPT or Jasper. That's been in a lot of the news recently. And students and professionals are finding that you can use these engines to do their homework. And often it can do it better and faster than they could have done it themselves. So the teachers are troubled, like how to keep their students from using these new technologies. And just a few days ago, Stack Overflow had to issue a policy forbidding the use of ChatGPT answers on their site, not because it was considered cheating or anything like that, but just because the answers that were being submitted from ChatGPT were wrong most of the time. So what do you do about cases like this? In most cases, the answer is probably going to be the same, which is the role of humans needs to shift from creating that content to more validating and editing the content that is generated by an AI engine. So consider a situation in the future where the teacher has the idea for the report or the essay that needs to be written, but the teacher herself submits that question to ChatGPT, takes the output and gives that output to everybody in the class. The assignment then is to validate, to check that answer, and then to edit it to create an accurate and readable report. So this is another situation where AI hasn't replaced the need for humans, but rather shifted the nature of the work that the human might be doing. So the second topic we're talking about is synthetic data. So one of my professors at MIT was Jackie Hewitt, and back in the 80s, she had the distinction of being the first person to actually discover an actual example of an Einstein ring in space. Now, an Einstein ring is where you have a distant star, and the light from that star is gravitationally warped through gravitational lensing to form what looks like a ring around a star. Now, she didn't have an ML model to help her. She found it just by looking at a whole lot of pictures of stars and galaxies. But if you had that problem today, how would you train an ML model to find that first Einstein ring? Where would you get the training data if none exists, none at all, because again, no human has ever seen one of these things. Well, you kind of know what it looks like from Einstein's predictions, and you could manually just draw some rings around stars. And that may seem very haphazard or ad hoc, but you could then use those manually drawn rings as training data. And you could also maybe train it to avoid things like nebula or similar known phenomenon. But that model that was trained on that manually created Einstein ring, that model would work just fine. It wasn't trained using real Einstein rings, but it could be used to find real Einstein rings. And that's the power of synthetic data.
So these look like nice people, but they aren't. they don't exist. They come from this person doesn't exist, does not exist.com, which is a wonderfully real, wonderfully surreal and thought-provoking, occasionally angst-inducing site that displays hyper-realistic people that are generated from algorithms. And if you play with it long enough, you may question your very concept of reality. But think about it. You can randomly assign these people names, zip codes, incomes, health problems, credit card numbers, and so forth, and be able to do it at scale. And just to make sure that you just need to make sure the statistical profile of your made-up people match the statistical profile of people at a much smaller set of the actual people. So the people you are working to profile and use for your testing data, maybe for an application you're building, you can generate that statistical profile that matches that. In this way, we can train our data and never have to violate HIPAA or PCI or child privacy laws. And we could still introduce bias. If our data generator is biased, then our data that comes out of this will be biased too. But synthetic data can really help when we need a lot of data that needs to look like a duck and quack like a duck, but doesn't actually have to be a duck. For me, and a lot of the work that I do with my clients is a lot of interface work. We do a lot of interfaces, or I do end up on projects with those, and HIPAA and PCI credit card data. And in the security world today, there's a lot of secure data challenges and PII that we have to deal with. And we don't want to take production data and necessarily just run it through a scrubber and test with that. But we want to use data that looks like it was generated for humans, not necessarily serialized or masked out and when we process it. We want to have something that's going to generate maybe consumer orders on an e-commerce site in ways customers would do it. That's going to test examples I may not come up with if I'm having to generate them by hand. With AI, data generation can do this without introducing that security risk, or when there is no data available source for that data.
So when would you want to actually create synthetic data? What are the use cases? Now, the first and most common is cases where you need a lot of data, but you don't have it. So this lack of real world data, maybe because the data doesn't exist, like in the Einstein ring example, or because the data is just expensive to gather or acquire. For example, it's much easier to go use a sample of voter data and then extrapolate that across the entire voter population, rather than trying to go and knock on doors and survey every voter in a voting district. The second use case could be dealing with moral or regulatory constraints. So these might include, like Matt had talked about, PII or PCI, HIPAA, child privacy laws. In these cases, making up fake data with fake credit card numbers is relatively easy and much less risky than using actual live data or production data. This third one, talking about one-way transformations, is a little bit trickier to explain, but we had a client that had survey data about their products, and this was in the beverage industry. But the survey respondents often abbreviated the product name when they sent in the surveys, and they abbreviate the standard way that most people abbreviate. They remove vowels from words, or they just list the first letter of each word. But once those letters are removed and all you get is an abbreviated string, how do you add them back in? How do you tie them back to your original products? In this case, it's a one-way transformation. It's really easy to abbreviate the words, but it's really difficult to unabbreviate back to its original form. One example that we had here was this abbreviation MCU. So you hear MCU, most people think Marvel Comics Universe or microcontroller unit. How do you know which one of those it is? And it turns out neither of those are products in the beverage industry. But what we did have was the product catalog. So we wrote an algorithm that, again, took use of that one-way transformation. We wrote an algorithm that would take each of the products in the product catalog and come up with dozens of possible abbreviations for each one of those products. And then we used those abbreviations to train an ML model to try to recognize those abbreviations, tie it back to the original product. So, and we could use that ML model that could then perform that backwards transformation that's so difficult. So the ML model actually found out that that original MCU abbreviation I was telling you about actually stands for Miller Coors Ultra type of beverage, a beer that actually existed in the product catalog.
Now, the next trend we're going to look at is report, automate, iterate. So based on recent surveys, the most common use for Power BI reports is exporting data and viewing that data in Excel. All the functionality for filtering, sorting, visualizing the data, people still want to pull that out and view it in Excel. And why is that? Usually it is because the business keeps evolving while the dashboards remain the same.
Yeah, so let's look at the evolution of dashboards. So you might start with a dashboard metric here on the left, and it might be something simple, like just a flag indicating whether or not you've run payroll in the last week. Now, the first few weeks that you're looking at that dashboard, if you see that that metric's in red, it's red flagged, then you're going to pick up the phone, you're going to call the payroll department and tell them to run payroll. But after a few weeks of that, you're going to get tired of that. You're going to automate it, right? So if the dashboard shows red, then you can have your BI tool automatically send a notification over to the payroll department itself. So at this point, your original metric becomes less useful. And you may want to update your dashboard then so that it's maybe a simple monitoring metric, or you may deprioritize it and remove it from the dashboard completely. Or consider another metric like the number of product returns in the previous week. This is a really good metric, but really it's just a starting point for a larger investigation. So after a few weeks of looking at that metric and then using it to start digging into all your return data and try to figure out why those returns are occurring, you're going to get tired of that. Of doing all that investigation and digging yourself, and you're going to want to update your dashboard so that when the data arrives on the dashboard, it's already segmented by the return reason, right? They could be reasons like it's damaged in shipping or it's the wrong size. And then you can start adding additional information to those segments, like what was the financial impact of those returns, or what's the percent of total sales that those returns represent. So now you have a way to start prioritizing and moving the top segments to the top. So now your dashboard is a little bit more prioritized, it's a little bit more actionable. So your business need is evolving and the dashboard has evolved along with it. But what if you hadn't made those updates to the dashboard? What if you hadn't removed those old measures or added those additional pieces of information or segmentation? Well, now you have business users that are staring at metrics that have already been addressed. Maybe their root cause is already addressed or they're no longer a priority. Or maybe they just indicate the presence of a problem, but without the details needed to do anything about it. So those dashboards, they have to evolve as well. They need to be updated on a regular basis. It could be monthly or at least quarterly. You need to revisit those dashboards and make those changes. Without those constant updates, those business users are going to start creating their own BI products, but it'll be hidden in the shadows, right? You're going to find managers who spend hours each week preparing Excel spreadsheets that only they understand, only they know how to use. And that's a sign that your dashboards are not keeping up with your business users. So the bottom line here is those dashboards are constantly becoming obsolete and they have to be updated and refreshed continuously to stay up to date.
So it's not just your BI dashboards that require constant updates. Your downstream processes and tools that you use that use your data need to evolve as your business evolves. And it starts with the data warehouse, as well as data in the data lake changes that'll impact your data warehouse. And your data warehouse could be impacted by your changing business needs. The point of the data warehouse is to serve the needs of the business, and those needs change, and the warehouse has to change as well. Then downstream, as we talked about the BI tool, like your Power BI dashboards and reports, your data science, including your ML models, must constantly be monitored and retrained as the data changes. You may have as many enterprises today also have data distribution products like High Touch or similar. Your distribution tools then feed your apps like Zendesk and CRM, and each of those systems must continuously evolve as well. And don't forget about the reverse ETL path, where the data needs to get back into the systems, back into the ERP systems, and those are going to have to evolve and work and continuously be updated as your business needs change.
So this fourth topic we're talking about here is active metadata. So where does active metadata fit into this definition of metadata? So in general, industry views three types of metadata. The first one here is static metadata. So these are things like the list of tables, the columns, your data dictionary. These are the things that people typically think about when they're thinking about metadata. They're really a lot like reference data. They really only change as often as your data model, so they're relatively static. The second along this line is the passive metadata. So these are the logs that track what jobs or queries have been run against your data, when they were run and who ran them, what columns they hit, what tables they hit, what rows they hit. So these are really tracking what data is being accessed by your business community. And then third along this spectrum is your active metadata. So that's what the topic is here. So this is basically automating a lot of the things that you wish you had time to do yourself. And it uses ML, it's machine learning models, to help make the data more accurate and more relevant to your particular use cases. So what are the types of things that ML can help to automate with your active metadata? So this first one here is like the automated flagging of risky data sets. Secondly, the automated search and discovery of data. Third, it can find the semantic relationships between data. Fourth, it can look for assignment of role-based user access. Fifth, it can actually automatically tag, profile, or annotate your data. And then lastly, that automated assignment of data types, so detecting and assigning data types. Now, today, these types of steps, this type of metadata is primarily the responsibility of your data steward. Or in some cases, it could be done through crowdsourcing, right? If you have a catalog tool that allows that collaborative crowdsourcing. In that case, all your business users or anybody accessing the data, like a data scientist, they can update that information in real time as they identify those potential risks or relationships within the data. Now, if we automate this through active metadata and we get those ML models involved, that doesn't necessarily remove the responsibility from the data stewards or all those users doing the crowdsourced collaboration, but it may shift the nature of their work. So instead of primarily identifying those risks and relationships, the people involved might now be more involved in validating the information that was created by the ML models. So again, this is just as we discussed previously when we were talking about AI, that role of validating is becoming more important.
So an example of a current project of mine where we are determining the full lineage. We have a source system and we need to know where all the data from that system is going, all its destinations and all the reports where it's used. Now, while my team can accurately document at the column level where all the data is going, it's much harder to understand the relationships, the semantic relationships between the different systems. Or maybe the column name doesn't match as it traverses that lineage, but it closely resembles or the name slightly changes, and we need to keep track of that. So what we did is we added metadata to our catalog. We augmented the lineage and grouped entities together, like every table, view, store procedure, trigger, Power BI report, so forth, data pipeline that is involved with moving contact data, my contacts or e-commerce orders, my semantic schema for contacts then is all grouped together with metadata. And I can see everywhere in my lineage that touches this. We had to add that manually and figure it out ourselves. Going forward, and the biggest issue is that it's manual and time consuming. And going forward, I want to get an AI process in there that I can train and work and be able to keep the system up to date as new systems come online that can keep my semantic relationships updated and in place for all entities, not just the handful, the 1 or 2 that I'm able to build manually.
Who would have a need for active metadata? And the answer is really anybody, but there is a cost and a difficulty associated with implementing active metadata. So there are some enterprises where, at least for now, it may make more sense to implement the active metadata. The first would be your large scale enterprises. Think companies like GE or Amazon, right? Where you have multiple divisions, you're spread globally, geographically, and that active metadata allows you to, at scale, give that searchability and find those relationships across multiple data warehouses, multiple data lakes across all your divisions. The second use case is probably very similar. This is companies that have grown through mergers and acquisitions. So you might have multiple BUs. And again, you want to get that searchability and that consistency across each of those BUs. So you have that centralized view, that virtualization to give you that centralized view across all your data. And the active metadata can help you do that at speed and scale. The third example here is companies that are ingesting unfamiliar data. So we have one client that's looking to try to ingest all their data from a mainframe system. So again, it's their data, but it's older data. And the folks who understood the data model in the mainframe system are no longer with the company. So they're using that ML capability to go out and discover the relationships, discover the data types, the types of data that would relate to their current data sets. And then similarly, you have like your third-party data sets, think like a Nielsen, right? So if you have addresses in your current data that include zip codes, then the active metadata can quickly identify that relationship between the zip codes in your data versus the zip codes in the Nielsen data, and therefore you can use it to tie the Nielsen demographic data against the for example, sales data that you have that's already coded by zip code.
Next topic we're going to talk about is MDM, or Master Data Management. Okay, so what are the shifting trends in MDM? Well, first, the industry is trying to step back a bit from the concept of master data management. There's been a lot of focus on MDM and MDM tools and processes that people are starting to lose focus on the end goal. And the end goal is this: a single view of trusted data. And this is what we should be talking about. This is a story we should be telling our executives and our champions and our sponsors. Nobody wants an MDM solution, but everybody wants a single view of trusted data. An MDM solution alone doesn't provide that single view of the data, but it provides a critical piece of the picture. But an MDM joined with a data catalog, processes for data stewards to own their data, to ensure the quality of that data and provide oversight, its definition, can produce that view, that complete view of that trusted data.
So the second trend that we're seeing with MDM has to do with operations MDM. So this is providing that single view of trusted data, but in your operations database instead of in an analytics database. Now, performing MDM in an operations database can be more difficult, takes more time, could be more risky, but it could yield more value and more efficiencies. An example would be like in your CRM system, right? Imagine using MDM to resolve the duplication of contacts or names, right? So not just removing duplicates, but merging that information like an MDM solution would. Now, you can identify and resolve those duplication in your analytics database, but you can see it would be much more useful if you could use that to clean up your live data, so the people who are using the CRM system every day can immediately reap those benefits.
Thirdly, it looks like, as for the different MDM products out there today, are moving to graph databases. The value of those table relationships and record linkage right in the database is a huge advantage for MDM processes. So look for almost all future MDM products and initiatives to be implemented using graph databases, either entirely or in part.
So the sixth topic talks about local and systemic analysis. So the example here is a hospital that wished to improve efficiency. And they asked each department to do an analytical analysis that included such things as their capacity, their staffing, their delays, et cetera. And this local analysis of each department yielded some ideas for improvements that could help those individual departments. For example, the emergency room says, can you allow us to divert some requests to other hospitals? And the admitting desk said, hey, we just need more staff. And the general ward said, we need more beds. But what the hospital realized is that while some of those suggestions might be helpful, some might not benefit the hospital overall. In fact, they might lead to different problems or possibly bigger problems. The emergency room wanting the ability to divert patients to other hospitals could help them, but diverting those emergencies to other hospitals can lower patient outcomes because of the additional time to reach the secondary location. The admitting desk wanting more staff doesn't do any good if there's no beds to put the additional patients. And the general ward wanting more beds is great, except that then that would require more nurses and staff to help support those additional beds. So some of these findings might be useful in a local context, but not in a larger hospital-wide context. So the hospital then went and did a macro data analysis. They used the individual department data. Again, this is the same data that was used at the local level, but this time they modeled the hospital as a whole using like a graph with nodes and edges, and each unit had an average stay time and outgoing probability to each of the other units, et cetera. So they ran some flow analysis and some simulated data through that. And this macro analysis yielded some comprehensive solutions. So some of the findings that they found there were that controlling the distribution of elective admissions could help. And this is things like using better scheduling to schedule your elective procedures. Secondly, discharging patients earlier in the day. Thirdly, increasing the number of patients discharged on weekends, which really wasn't being done very much at all. And then fourthly, having a full capacity action plan. And this fourth point is especially interesting because for peak efficiencies, hospitals always want to be operating near their full capacity because any spare capacity represents inefficiency in the form of lost revenue. So increasing capacity by adding beds or hiring staff doesn't actually solve the problem. In fact, it tends to increase the inefficiency in the form of empty beds. So by looking at this problem systemically and modeling the flow, the hospital was able to identify ways to reduce that inefficiency, reduce the empty beds. The problem then becomes how to deal with those temporary instances where you're operating at full capacity, which actually becomes a lot more common in a system that's designed for having that minimal buffer. And since those situations are more likely, then it makes sense for the hospital team to train, be able to recognize those situations that they're operating at full capacity, and then train their staff on how to deal with those situations where they're at maximum capacity. And for every department to have some level of contingency planning on what to do in just those situations. So what's the takeaway here? So most analytics projects or data warehouses, they're going to start with the company's ERP data, right? That localized data. And that's good. That is the right thing to do because ingesting your ERP data is fast and it's easy. And measuring that time to value is a real thing. But don't stop there, right? Imagine you're Nike and people have stopped buying your latest shoe model. Then what are they buying? Right? Your ERP data is not going to tell you that. For that, you're going to have to go to second-party data or third-party data. And your analytics database is going to have to evolve and grow to ingest that data. And that is what's going to allow you to kind of zoom out and get that big picture so that you can see your data from your ERP systems in the context of the entire enterprise or the entire ecosystem of companies that you're working with or your overall industry. So analyzing data at each of these levels from the micro to the macro may yield different insights. And those new insights may run counter to what you might assume just by looking at your own department data or your own company data. So there's a whole world of data out there that can be ingested and then analyzed.
So that concludes the 6 topics we wanted to talk through today. I did want to invite everyone to our next Co-Strategics webinar, which will be on January 19th at noon. The topic is how low code, no code can help business teams create value quickly. My colleagues, John and Zach, will discuss how IT teams are learning to embrace citizen development by controlling the governance of rules, roles, and responsibilities. They will walk you through enterprise level low code, no code solutions, ways to get started, and how to build a center of excellence around low code, no code applications. A quick overview of our company. Co-Strategics is a strategic technology consulting and implementation company that bridges the gap between technology and business teams to build value with digital and data solutions. If you're looking for guidance of how to mature your data analytics capabilities, we can help you leverage best practices to enhance the value of your data.
So Matt and I are both in the data and AI solutions group at Co-Strategics, and this slide shows some of the services we have. But the real benefit of working with a company like Co-Strategics is the partnership that we bring for co-innovation. We work with your team to deliver speed and value on your data projects.
Great, thank you very much. We had 2 questions that came in here, but feel free, if you have questions, just type those in the Q&A and we'll get to those if there are any last questions here. The first question that came through is, do you recommend that dashboards need to be updated monthly? And do you see other companies actually doing this?
Monthly, dashboards being updated monthly is a maturity target I think companies need to get to. What we see more is about quarterly, where in a month, business users are going to use it that month, and business analysts in the second month are going to go back and get learnings from those business users and see what do they want to change, what are some new problems that need to be visualized and so forth, or what can go away, is no longer needed. And then that third month you get development and rollout. But it's definitely a goal to get to, or at least in a cycle of monthly updates coming, even if there is a little bit of longer time for development and analysis. You do want them coming often. Visualization tools are being updated on a monthly basis. There's always new updates coming out. And so developers are always watching and finding new things to do, and need to be also bringing those up to the business users to provide new ways they can look and see their data.
Yeah, and I think I would agree with a lot of Matt's answer. I think this is, in some cases, it's aspirational, but this is the direction that a lot of business users would like to go. A lot of companies would like to go, and then it's just a matter of implementing the speed and frequency in order to get to that level.
Great. Another question that came through is, where does responsible AI come into your thinking, especially when many of the companies behind the AI are not necessarily responsible? For instance, my kids use an app that shows them what they're going to look like when they get old, but the app then owns all of the images of all the kids who use the app.
Yeah, so one thing we've noticed in the AI space is that the people building the AI solutions and platforms are putting in responsible AI sort of technology or functionality. I know Azure, Microsoft are doing this and bringing that in from their AI platform partners. But while it's great that these solutions are being built and the AI community is talking about ways to have AI be responsible, but it is then coming down to the humans who use it, companies who are then going out and using it, providing, say, a free service, as Audrey mentioned, the kids uploading their own pictures, and then the generated pictures and things are uploaded, they own that. Well, why is that? Was that being responsible? Are they using it to gather data? Where is that going? I could go on about other companies and social media and so forth, but it is a place where AI is going, and people are using that for their own means, even if the AI itself is being responsible.
Yeah, that idea that we talked about, where that nature of the work is shifting, and we talked about that idea of curating and validating, that's not only a shift in role, that is becoming a responsibility for, in some cases it would be the data steward, in other cases it would be the data scientist who's responsible for maintaining that ML model. And as an example, right, we have a client where we process about 2 million records a day through our ML models for that client. And we do have auditing in place, manual auditing, and we only audit probably 100 or 200 records per week. So you can see that's just a tiny sliver of these millions of records that we process, but you can still get good insights from those couple hundreds records that you're auditing, right? So, you can't just, it's not a fire and forget. You can't just put your ML models in production and let it go. You're still going to have to put some effort into that manual auditing. Make sure that those decisions that are being made by your AI are the same types of decisions you would be making yourself, right? So being able to put in that effort and keeping an eye on those decisions that are being made is the responsibility of the data scientists as well as the business users.
Great. Well, that concludes our webinar for today. We are out of time. Thank you so much for joining us. Please don't hesitate to reach out to Jeremy, Matt, or myself if you have any further questions, and have a great rest of your day.